Today we are going to be talking about dimensions of physical quantities. What is dimension of physical quantity? It's simply the way it is related to mass, length, and time. Okay? Now, before we go into detail, let's quickly talk about fundamental quantities and derived quantities. What are fundamental quantities? Fundamental quantities are the basic quantities. Okay, they are the basics quantities. Okay, now why derived quantities are those quantities that are dependent. Fundamental quantities are independent, derived quantities are dependent. Okay, for example, because this topic today is going to depend on fundamental quantities, since we need, or rather dimensioning of quantity is based on fundamental quantity. Okay, now examples of fundamental quantity. We have examples of fundamental quantity. Examples. Examples of fundamental quantity. Use this acronym. We have what we call LT meter. LT meter. Okay, where L is for length, T for time, M for mass, E for electric current, T for temperature, A for amount of substance, and L is for what? Luminous intensity. Okay? Now, usually in dimensioning, we use these three. Okay? Length, time, and mass. Length, time, and mass. Okay, let me quickly bring it out here. I said we'll use this L, T, M, E, T, A, F. LT meter. These are fundamental quantities. So I said this is length, T for time, M for mass, E for electric current, T for temperature, A for amount of substance, and then L for luminous intensity. Okay, let's quickly put the units. All these I mentioned, they are called fundamental quantities. Fundamental. Like I said, they are independent. They are the basic quantities. Okay? Now, the units of these fundamental quantities is called fundamental units. Fundamental units. So the unit for length is meters. Okay, the acronym is the symbol is M. The unit for time is second, and the unit is S. The unit for mass is kilogram, and the symbol is kg. Electric current is ampere, and the unit is capital letter I. Temperature is Kelvin, and the symbol is K. Amount of substance is mole, and the symbol is MOL. think small letter M-O. Then luminous intensity is candela. CD. So here we have the fundamental quantity, and then we have the fundamental unit. Like I said before, the unit of fundamental quantities is called fundamental unit. Let's quickly talk about derived quantity. Okay? Derived quantity depends on fundamental quantity. They depend on fundamental quantity. Usually, it's a combination of two or more fundamental quantities. Okay? So we have examples of derived quantities. Examples of derived quantities. We have 1, area. We have 2, we have volume. We have 3, we have what we call the velocity. We have 4, we have what we call force. We have 5, we have what we call acceleration. We have 6, we have what we call the momentum. We have 7, we have what we call moments, and so on, and so on. Okay? When you have combination of 2 or more fundamental quantities, they are termed derived quantities. Is that okay? Now the units of all this, the unit of these derived quantities are termed derived units. So without much ado, let's go into the topic for today, which is what? Dimension of physical quantities. Let's start by dimensioning area. Now, in dimensioning, we usually dimension using mass, length, and time. Okay? Now, for mass, the dimension is usually capital letter M. Then for length, the dimension is usually capital letter L. Then for time, the dimension is usually capital letter T, and so on. So let's quickly dimension this derived quantity that we have here. Let's start with the simplest. Okay, we'll start with the simplest, which is area. Now, to dimension, there are 2 ways we can dimension a quantity. Okay, it's either you use the formula method. If you know the formula, you can use the formula to achieve dimensioning, or you use the unit. If you are so sure of the unit, you can dimension through the unit. Let's go. We'll try the 2 methods and see which we prefer. Okay, let's try number 1, dimensioning. The following. We have 1, area. Like I said, we can use 2 methods. Let's start with the formula method of the units. Okay, now the formula, we know area is simply length times breadth. Okay, length times breadth. Right, now length is clear because what we are going to be needing is simply M, L, and T. Mass, length, and time. Whatever we are going to dimension must be dependent on these 3 quantities. So now we have length and we have breadth. Breadth is also synonymous to length. So we see this as length, which is equal to length times length. Is that okay? So we cannot say, like I said, if you are dimensioning length, you use capital letter L to replace length. So we now have, if we are replacing this L with length, we have what? L. We replace this other length, we have what? L. So the dimension for area is simply L raised to power what? 2. Now, if I want to use formula, the unit method, by now you know that the unit for area is meter square. Meter square. Meter is a unit for what? Length. So you simply put L square and that's all, using the unit method. Okay, let's try the second one. 2 volume. Okay, it's simply the multiplication of 3 lengths. Length times breadth times height. So I'll just go straight, which is the same thing as length times length times length. Okay, like I said, this is what replaced with what? L, and this one is replaced with another L. This one is also replaced with another L. L times L times L is equal to what? L cubed. Now the unit of volume is what? Meter cubed. So from the unit meter cubed, meter is used for what? Measuring length. So we have meter cubed synonymous to what? L cubed. 3. Velocity. Velocity. Let me start with the unit method. We all know by now that the unit for velocity is meter per second. So if the unit is meter per second, we know that this is meter per second is the same thing as meter over second. So if you have this, meter goes with what? Length. So we have L. Second goes with time. So we have T. So the dimension is what? LT raised to power 1. This is the dimension for what? Velocity, using the unit. But if you want to use the formula method, we could simply do this. We have velocity is equal to what? Distance over time. Distance is simply the gap between 2 points. Distance is simply the gap between 2 points, okay? Which is equivalent to length. So we can say length over time. So wherever we see length, we put L. Wherever we see time, we put T. So we have L over T, which is the same thing as what? L T raised to power minus 1. It's the same thing. Okay? Now, the next one we are going to be doing, let's do acceleration. 4. Acceleration. Let me use the unit method first. What's the unit for acceleration? Is meter per second square. Okay? Meter per second square. So we have meter all over second square. Length goes with what? Meter goes with what? Length. Seconds goes with what? Time. So we have this. Okay? Which is equivalent to this. LT raised to power minus 2. This is what? The dimension for acceleration. Now let's do the formula method. Remember, MLT, mass length time. MLT. So let's do this. Formula method. Yeah, acceleration is simply the rate, the increase in the rate of change in velocity per time. Increase in what? Velocity per time. So the formula for acceleration, which is denoted with A, is equal to what? V minus U all over T. We can simply put dV over T. That's velocity over time. Okay. So now if you have something like this, V does not go with anything here. So we simply break down velocity again, like we are dimensioning velocity again. So to save time, since we have done velocity before, I will simply put the dimension of velocity here. I'll bring it here. So it will now be what? LT inverse all over T. Is that okay? Now, we have this, right? LT, this is the same thing as 1 over T, right? I bring this, if I remove this all over of the inverse, we have this. Okay? T minus 1. Indices, the law of indices. We add the power. Then you have this LT minus 2. LT, where is it? LT minus 2 using the unit. LT minus 2 using the formula method. Okay, lastly, let's quickly look at force. 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 What is force? Force is simply N A. Force is simply what? The formula of force is what? MA. So how do we do this? We have this. This is simply the dimension of mass. The dimension of mass times the dimension of acceleration. The dimension of mass times the dimension of acceleration. Okay? The dimension of mass is simply capital letter M. Since we have done the dimension for acceleration, there's no need solving all over again. I already have it here as what? LT minus 2. So the dimension is equal to what? MLT minus 2. This is the dimension. Now let's use formula method. The unit method. So what is the unit for force? The unit for force, if you've forgotten, we know you have MA. F is equal to MA. Remember that the unit for mass is what? Kilogram. The unit for acceleration is simply what? Meter per second square. Okay? So now, kilogram goes with what? Okay, let me further break it down. We have kilogram meter all over second square. This is all over. This is the same thing as all over. Okay? Meter per second square is the same thing as meter all over second square. So if we have this, kilogram goes with what? Mass. Meter goes with what? Length. Time, seconds goes with what? Time. So we have this t square, right? So this is the same thing as what? ML, okay, times 1 all over t square. If we bring this up, we have what? ML t raised to power minus 2. Okay. We can go on and on. We can go on and on. So, dimensioning is simply doing quantities in relations to what? Mass, length, and time. Okay? I hope you enjoyed the class, and I would like you to try doing a dimension on pressure using the formula method and also using the unit method. I'm still Joseph.